Hello everybody, in this new tutorial of NetCore 3.1 Web API. So today I'll show you how to how to set up a Web API project with Entity Framework. So before beginning the coding, let's show you the Web API architecture schema. So in general, we have two parts here, the client application and for the front end and web API for the back end. So the front end can be a Xamarin Forms application or an Angular web application. In communication with the backend, and the backend is web API. It's composed in general. We can find four components. So we have the data access layer or DAL. It's composed by repositories and the DB context. So the DB context is the entry point to the database. The repositories contains all the operation, CRUD operation, create, delete, modification, etc. And we have also another component, I don't mention it in this schema, it's the unit of work. This data access layer is in communication with the business logic layer, the BLL. This BLL contains in general the manager, and we can find other components like engine or core. So it's encapsulate all the business rules. This business rules is in communication with Web API, which is secured by which called the security middleware authorization and authentication. So when user try to log in the first time, he types the login password, and we call the authorization component in which we will return the HTTP request, the authentication token. And every time the user call or make HTTP request, we'll verify this request, the authorization, this authentication by the authentication component. It will be verify the token. So let's move to our solution and create. I've already created a refresh token web API project. So now let's create a new project called refresh token.modules. It will contain all the data structure, and we need to create also the repositories project. And finally, we need to create a manager's project. So here we have four projects. Now let's organize our solution by creating solution folders. So let's create the first one, which is called BLL, in which we put the managers project. Here we have the data access layer folder, in which we'll put the repositories. And finally, we'll create a data layer. It will contain all the data structure like models, enumeration, DTUs. And finally, we have the API folder, in which we put the API project. So here we have in general our architecture, Web API architecture. Now let's move to the models project, and let's create a new class called user model. It will represent a user in a real world. So before that, let's create a new folder called entities. So entities will represent all the class any class that represents a table in database. And we have also another folder called enumeration. So we need to separate these classes in order to organize our model project. So a real project will find some hundred of entities and enumeration. So it will be not maintainable. So here let's move the user model under the entities folder. So the entities, when we have many entities, in real case, it share a common properties like the ID, the creation date property, the modification date, delete date. So that's why we need to create a base class called base model, in which we define this common properties like the ID, type of long, and we have also the modification date, type of date, the creation date, and the delete date. So the delete date is used to make a logical delete operation. In real world, we don't delete immediately the record or the items from database. It will be deleted after that by a programmed job. And the delete date cannot be nullable. That's great. So the user model class derived from the base class. So the user model here extends all the properties of the base class. So now let's represent the user by real properties in the real world, like the first name, the last name, the email, and the password. Now we need to create a new enumeration in order to define the status of a user model. So let's make a public enumeration called status enum, and that will represent pending, active, and delete state of the user. In the real world, when you sign up, you have an account under a pending status, and when you validate your emails by clicking on the link sent in confirmation email, your account will pass in the active status. So no, we need to create the database context. That's why we need to install a NuGet package called Microsoft Entity Framework Core, and we need to accept the license. And here, let's rename class to refresh token context, in which this class is derived from the DB context from Entity Framework class. So let's add the constructor here for the refresh token context, and this constructor take a DB context option in order to inject the dependency from the startup file, CSS file. So we need to define the DB text context options that will contain the connection string to the database. So now let's move to the repositories, and we need to define here the common part in this repository. So in the measure of cases, our repositories or our table satisfy common behaviors like the CRUD operation. So that's why we need to create a generic repository that satisfies, let's say, 90% of all the tables in the database. And if we have a special case like update by a list of items at the same time. So we need to define or specify this a special case. So we need to define an interfaces of a generic repository and a unit of work. So the generic repository and the unit of work is best of practices. You can find it on Microsoft site web, the official site web of Microsoft. And so the repository is responsible only for make operation. He don't care if the operation is saved or not. So that's why we defined all the code operation in the generic repository, and after that we use the unit of work to commit or not the operation in the database. So that's why we need to define the unit of work in which it will contain only the commit or the save changes method, and it will be disposable, of course, in order to liberate a session when we open a session on database when we make operation. So now let's define the unit of work class. So we need to add a new constructor that take the refresh token context. So here we need to add the refresh token context project and the references. And let's define the property. It will represent the database context, so private refresh token context type, and let's rename it to db context. And inside the commit method, we need only to call db context dot save changes. That's nice. Now, this unit of work implements the iDisposable interface. And finally, we need to add the dispose method in order to liberate the resource. So we need to make a dispose. It's take a boolean parameter, and we call the garbage collector in order to suppress, finalize of this unit of work of this resource. Now let's move to the generic repository. It's a generic, so it take a T entity type, which will be a type of class, and inside we'll define the common CRUD operation. So here we have a generic get that will contain a filter and order by. We can have also the get by ID, the delete, the update, and update all, for example. This all operations are common between my entities. So now let's move to the generic repository class, and it implements the iGeneric repository type of T entity, where the T entity is a base type of base model. So the base model is a class. Now let's redefine this method. So let's begin by adding the generic repository constructor that take the refresh context, database context. And we need to define two properties here, the refresh token context and the db set property type of T entity. So this is the generic behavior here. So when in the constructor, we need to define these two properties by initializing the refresh context and the db set. That's great. We will not see in details this method because it exists on the web, so you can take it and paste it and copy it and paste it in your project simply. So now let's move to a new interface called iUser repository that implements the iGeneric repositories type of user model. And let's create a new class also called user repository that derived from generic repository class type of user model, and it implements the users repository. That's great. And here we need only to define the constructor, and we have done here. That's cool. This is the advantage of a generic repository. So when you have a new table and you need to query it, so you have to define only a new repository and extends the interface and the generic class repository. That's cool. Now let's move to the business layer logic, and we need to define the manager. So like the generic repository, we have also something like this in the manager, but here we need to make only a base manager in which we can add all the common properties used between the managers, like UNTF-work. So we need to add our user manager, in which we'll define all the business rules here, and its interface called iUser manager for the dependency injection. So this user manager derives from base manager and extends the iUser manager. And let's make this class public. So let's define the common property in the base manager. So eventually here we need at the moment the UNTF-work. So let's add constructor, and it takes UNTF-work like a parameter. It will be injected from the container of dependency. So now let's create a new property called UNTF-work, and it will be protected for the derived classes. So now let's define the operation we needed in the iUser manager. So here we need to, for example, get all users, and we return an enumerable of user models. And we need to make a login operation. So the login operation takes a DTU. We don't send a real user model. That's why we use a DTU in which we have the email and the password property. So we don't need, that's all we need, in fact. And here the login method will take a login DTU, and it will return a user model. And finally, we need to add insert method and update method. Cool. Now let's go to the user manager and implement this interface. So here we have all our operation. So Obviously, we need to inject the iUser repository in order to query the database or the users table. That's cool. So we forgot the ID here. That's nice. Now, to make the delete operation, we need to call the user repository.delete by the ID, and we need to call the UNTOFORK to commit the operation. So the repository responsibility is to make the operation like delete, and the UNTOFORK responsibility is to commit or to save the operation if it's possible. Now, in order to get all the users, so it's simple, we call the user repository and we get all the user where the delete date is equal to null, which means all the user not deleted yet. And we can add also in the active state if we need it. So the insert, we need to pass the user model and we will insert it and make the commit, and the method will return the ID of the inserted user model. Finally, we need to make the login operation. So here we need to verify if the login detail is not null, or the email is not null, or the password is not null. So if is the case, we return null, else we'll make a simple get. So let's call the user repository dot get, and let's make search or filter. So the delete date is equal to null, and the email is equal to login dtu.email, and the password x.password is equal to login dtu.password. So it's not so here our password is clear in the database, and it's not the objective of this tutorial to make cryptographic and secure the password in the database. We'll see that in next tutorial. So here the objective is to store the item in the database, and that's all, to show entity framework, how entity framework works. That's nice. So here we need to get all the items, and it will be single or default, so we are sure that we can get at maximum one user. So in the update method, let's take a user model class or object, and here we need to search the target user, and after that, if we have something, so if the target user different from null, we'll make the update operation. So we need to modify the modification date, call the user repository update method, and we pass the user model, and we call the UNTOFORK and make a commit. It's simple as that. Else we return null. So we can't find the target user, so we don't make changes here, so we return null. And eventually, don't forget to modify the password. So we need to conserve the password because we don't know if the operation will change the password or not. So we'll take the simple case. We are not in the profile user to make change on a password at the moment. So we'll see this in the next tutorial, how to make to distinguish the operation between update personal information, or we need to update also the password. So here in the insert method, we need to add a status of the user, and by default it will be a pending status because we insert a user one time when we sign up. So by default it's pending, and if the user need to have active account, he needs to confirm his email by clicking on the link on the confirmation email, send it on the mailbox. So now we need to make which called extensions method in order to return or in order to define a new method, extension method called without password. When we call the API in order to get an information of the list of users, for example, we need to delete the password for a security reason. So that's why we need to define a new extension method called without password, and it takes a user model object, and inside we need to define user model.password is equal to string.empty, and we return the model. It's simple, and so we need to define also without password that takes an enumerable of user models and return the list without password. So here when we make a login, we return a user model without password. It's for security reasons. It's as simple as that. So you can call simply without password at the end of operation. And we need to add the reference to the tools project, and it seems good. Now when we call get all user also, we need to define without password, and I think that's all for the moment. So here we forgot to make the return user model. So that's all for today. Thank you. See you in the next tutorial.